Hi everyone, welcome to our fourth tutorial in our imaging science series. My name is Brian Murnoff. I'm the education coordinator at the MIT Museum, and today we're going to be looking at astrophotography. Astrophotography is a great way to familiarize yourself with the motion of the Earth and the stars and the planets and satellites and the space station. There's so much stuff out there, and astrophotography gives you the time to take some time, look up at the stars, and discover something new. Astrophotography presents its own set of unique challenges. Things such as light pollution from nearby buildings, or even light from the moon. You don't realize how bright the moon is until you start trying to take images, especially when the moon is full. You're also competing with the weather. So, oh no, if there's clouds on the night that you want to go out, you're not going to be able to take star pictures. So the weather is going to get away, as well as the fact that there's really just not much light. The sky is dark at night. So we're going to look at several techniques that we can use to help get around these challenges and take some really cool astrophotography shots. It is also important to note that because our subject, in this case, the sky at night, is very dark, it's going to be difficult to get enough light. Cell phones, because their lenses are very small, have difficulty gathering this light. So your images from a cell phone are not going to be as clear as those from a camera with a larger lens. But that being said, we are going to cover some techniques in this tutorial that'll help you take some pretty good astro photos, even if you're shooting with a cell phone. In order to get around some of the challenges that I previously mentioned, there's some things that you can do in preparation to do astrophotography to help you. The first one is there are many applications out there for your phone or computer that are guides to the sky. They'll tell you when certain things rise and set on the horizon, where they're going to be, and these will be very helpful in planning what you would like to take pictures of. The next one, also a phone application or on your computer, is check the weather, especially hour-by-hour forecasts. You can see that actually this is the forecast from today when I'm recording the video. It's actually going to be very clear tonight, which is great for astrophotography. You want to avoid, obviously, clouds and rain, so plan ahead. The next thing that I recommend is a flashlight. Now, not just any flashlight. If possible, use a red flashlight. Red flashlights do not ruin your night vision as much. It takes a long time for your eyes to adjust, and you'll notice the longer you spend outside, the more stars you're just going to be able to see with the naked eye. So by using a red flashlight, you'll still be able to light things in order to adjust camera settings or whatever you need to do, but also not ruin that night vision that you work so hard to get. Lastly, astrophotography does take patience. We're going to be taking some long exposure photos. We're going to be taking lots of images. We'll be waiting for clouds to pass. We'll be waiting for things to come above the horizon and out of the way of trees. So even during the summer, it gets kind of cold at night. Dress warmly. So bring some warm clothes, sweatshirt, gloves, whatever you need, because it will get chilly out there. Now that you have what you need to start shooting, let's start talking about our camera settings for our exposure triangle. The first thing we're going to talk about is aperture. Now, with astrophotography, because everything we're photographing is so far away, what we say it's all at infinity, we don't have to worry about depth of field. So we can shoot with a very wide aperture or your lowest aperture settings. f1.4, 2.8, 3.5, whatever the lowest you can set if you're using an interchangeable lens camera. By having a wide aperture, that will also help you capture more light, let more photons enter your camera to give you a brighter image. Now, with that though, because your depth of field is low and you're focusing on something far away, focus is very important. So whether you're using a cell phone, a point and shoot, interchangeable lens camera, it's really easy to get out of focus stars. And I've had lots of nights when I've gone out to shoot and I come back to look at my images and all my hard work, I end up with these types of blurry images, and it's because I was slightly out of focus. So What I recommend in order to make sure you have these pinpoint stars is to use manual focus and take lots of test shots. So turn off the autofocus on your camera. You're going to use the manual focus setting. Focus it, look in the camera, try to get them sharp, take a picture, then zoom in and check to see if your stars are in focus. If they're not, adjust and try again. And do that a few times to make sure that when you start spending a lot of time taking your photos, you get really sharp stars. Now, the next settings we're going to talk about is the shutter speed. Now, in order to capture the most light as possible and get a bright image, you're going to want to use a fairly long shutter speed. When you use long shutter speeds, because you're capturing more and more light, you're going to start being able to see all these dim stars that you may not be able to see with the naked eye. So you may discover some new stars just by using this long shutter speed. Now, when you do this, I recommend that you use a shutter speed that is no longer than 30 seconds to keep your stars as pinpoints, so keep your image really sharp. Now, the reason why I say 30 seconds is that the Earth is spinning, and the Earth is spinning once around its axis every 24 hours, and what that causes is motion blur. So you can see in this image, this isn't due to camera shake, but this is due to the motion of the Earth as it spins, that these stars are getting stretched out and you see these trails. Now, these trails can actually be used for a really cool effect. You may have seen images with star trails, and we'll talk about how to take images with these star trails on purpose a little bit later in this video. But if you're trying to get pinpoint stars and see lots of stars really clearly, be careful about setting your shutter speed to be too long. So the long shutter speed allows us to take brighter images even though there's not much available light in the sky, but it also introduces another problem: camera shake. So if your camera moves during that long exposure, during that 30 seconds or 15 seconds or whatever you're using, you're going to get blur. So it is super important to use a tripod. Now, it's okay if you don't have your own tripod, because I'm going to show you now how to make your own stable tripod for whether it's your phone or your camera. There's a bunch of different ways to do this. The important part here is that the tripod is stable, meaning it's weighted down or connected to whatever surface you're using in a way that is going to prevent it from shaking. Now, firstly, don't forget the simple solution. So we could always just put our cameras face up at the sky. This actually works surprisingly well. I've taken photos like this, and it works as long as whatever you want to image is straight up. It also prevents you from seeing your screen, so if you want to take multiple shots of the same thing, that will be a little bit of an issue, but it's the quick and simple solution. If you want to point your camera at a specific point in the sky, there are a couple of different options. So these are some that we came up with here. And so this on the left is a quick clamp that's holding the cell phone very stably. And I added this weight here in order to keep it locked down to the surface. And that worked actually really well for long exposures. Here's another one that we built using cardboard, and this, by taping the edges here in different places, you can adjust the angle that your phone is pointing to also aim your camera. And a third example here is using a cardboard tube where I've cut out slots here for the phone. The phone sits here, and then I've weighted it down. It happens that this tube fits right in the tape, and the tape is holding this down to the table to make a stable tripod. For larger interchangeable lens cameras, you can actually use a similar system. So in this case, I'm actually using the exact same cardboard stand I used for the cell phone, but just prop the camera up on the other side. And here's the picture in the middle here is the back view of that. And I'm just using this tape here to provide a little extra stability to the camera. This lets me access all the controls to the camera while keeping the camera in the same place. And the last example here, it's similar using cardboard, but this design allows us to weight down our stand a little bit. So we're using some coins here to keep our camera pointed in the direction that we want. So again, super important when you're using these long exposure times, make sure that you have a stable tripod or your pictures are going to be blurry. The last setting that we're going to look at is ISO. Now, for your ISO, higher values are going to allow you to capture more detail, especially if we're looking at things like the Milky Way, but it also adds more noise. So you're going to want to pick an ISO based on your particular camera and how much noise your camera is going to produce. This will also be affected by how much light pollution is around, because a higher ISO not only makes your camera more easily detect light from the stars, but also light from around you. So you can see in this picture here, I used the high ISO, which allowed the stars up at the top of the image to be nice and bright, but at the same time, it captured all this glow from the city down here. In my Milky Way shot, you can see, again, lots of color. You can see detail in the Milky Way. You can even see some shooting stars, but it's a little bit grainier. So there's some greenish purple in there. That's actually a result of using high ISO. In some cases, and it's personal preference, how much noise you would like in your image, so definitely experiment and see what it looks like. Now here's an example with really high noise. So in this image, I've boosted the ISO really, really high so you can see, and you can see all the graininess here and the different colors in the image, and that's caused by having ISO that's too high. So again, can't really give you a specific number, but you're going to have to experiment with your camera to balance the amount of noise and the amount of detail and brightness of the image. But in general, try to rely on your shutter speed and aperture to get the exposure before adjusting your ISO too high. So now that we've talked about how to take nice sharp images with lots of stars, let's see how to take advantage of the spin of the Earth to create some effects that will create some really stunning images. So what we're going to look at are what are called star trails. And so in a star trail image, you're actually tracking the movement of the stars over time. So as the Earth is spinning, it's going to look like the stars are rotating around in the sky. And they're actually going to be rotating around, or seemingly rotating around, the North Pole or the North Star. So in my image, you can actually find where north is by the center of all the rings. So if I follow these circles here, the North Star is right behind the trees here, where all of these stars are circling around. So this photo was created by stacking many images of the sky over the course of 2 hours on top of each other. So this isn't a single photo. And to take this, the shutter speed for each of those photos, it was probably about 100 photos here, was 30 seconds. And you could actually even go a bit longer. And by using a long shutter speed, it allows the stars in the images to move a little bit, and you get a little bit of motion blur in each image. And many cameras have what are called intervalometers built in. These let you choose the shutter speed of your camera and how often you want your camera to take a photo, so you don't have to stand outside for the full 2 hours. So you can set up the intervalometer, point your camera, focus it, start it, go inside, enjoy some hot chocolate, and then go out and check your camera every once in a while just to make sure that your battery isn't dying. And once you have all of those images, let me show you what they look like. So you can see as I take the images over these 2 hours, the stars are circling around that North Star. So we can now insert these into, there's a lot of free software out there. In this case, I'm using one called Star Stacks. And when I put this in the software and click stack, you can see that it's going to blend these images together in order to create consistent trails across the sky. This is why you want a little bit of blur in your photo, a little bit of that motion blur to help connect those images together. You can see in a couple of points in the image, you can see some dots, and that's because my shutter speed was probably just not quite long enough in order to fill in those gaps in the photo. Now let's take a step away from stars for a second and talk about photographing the moon. A lot of you have probably had this frustrating experience of you see the moon up in the sky, it looks big and bright, and you see all the details, and then you go to take a picture of it and it looks like this. It's a tiny bright dot. So let's talk about why this happens and then talk about a few ways to avoid this, to make the moon look like it looks like to your own eyes. The reason why this is a problem is that the moon is relatively small compared to the things around you on the ground, in the sky, and it's also very bright. So your camera, especially in a cell phone, is going to have difficulty exposing for both the dark part of your images and the bright part of your images. So the moon gets what we call blown out. It's so bright that we just can't capture any detail. It's also really small, so it's hard to pick out those details. So how do we solve these problems? Well, the first thing is it's really small. So what I recommend is taking your photo, if you have one, through binoculars or a telescope, or if you have an interchangeable lens camera, use something with a long focal length. The more that you can zoom into the moon or into your photo, the more detail you're going to be able to see. This picture in the middle here, for example, this was taken through the telescope with the cell phone, and you can see a lot of detail here in the moon. So this helps us get at the moon is very small problem, but how do we solve the brightness problem? So even if I can zoom in, here's a picture of the moon, and it's still very bright. So how do I get my image to be darker? And you can see in the image on the right here, there's a lot more detailed. I can see the kind of striations near the south pole of the moon here and the different types of rock. A lot more is becoming clear. So to do this, use a shorter shutter speed. So a shorter shutter speed is going to get rid of a lot of that excess light. And we can also decrease our ISO. And this is why, again, it's super important, as we've talked about in previous tutorials, to have access to manual settings on whatever camera you're using. By raising that shutter speed and dropping the ISO, you're going to be able to capture images of the moon that are much more detailed than you were able to get before. Another tip for photographing the moon that's actually even easier than adjusting your settings, you can even do this on auto mode, is photograph the moon during the day. During the day, you don't have that huge range of light, the darkness of the sky versus the really bright moon. Everything is at a more level brightness, so your camera is going to be able to expose the image a lot more easily. So if you haven't tried it, try taking your image during the day, and you're going to see a lot more detail than you do at night if you don't have a telephoto lens or binoculars around. To wrap up, the last thing I would like to talk about is how to add something a little bit extra to your photos to make them really interesting. And this is going to be foreground. And it's great to take images of what we call star fields. They're really interesting. You can see all the number of stars. You can look at specific stars, constellations. But you can make these photos a little bit more interesting by adding some context to them, by including some foreground. So let people know where you are. Where was this image taken? What do the stars look like relative to where you are? And this can be a little bit tricky because the sky is really dark. There's not much light on the things around you. But if you expose your camera and make your settings so that things close to you are really bright, then you're not going to be able to see the stars. Or if you expose for the stars, then the things in the foreground are going to be way too bright. So how do you control that? And in a lot of times, the images that you see that have foreground in them are actually what are called composites. So what you would do is take an image of the stars and expose your, set your settings, expose for the sky, and then you do a separate photo that has the correct exposure for what's in front of you, and then you combine them. But there are a few ways to actually do this without using any software. So what you can see here is I actually did what is called light painting. And I set my camera up so I'm exposing for the stars. So I use a long shutter speed in order to capture the detail in the sky that I want. And then what I do is during that exposure, I take a flashlight. So in the first picture, I use a flashlight. In the second one, I'm using just the light from my cell phone. In the third one, I'm actually using moonlight. The moon was really bright that night, so I couldn't actually see the Milky Way, but it ended up lighting this castle in a really neat way. But using the ambient light to light the things around you. So if you're using a flashlight or a cell phone, what you can do is just briefly, so let's say you're doing a 30-second exposure, turn on that flashlight, shine it at the objects in your foreground that you want to be able to see in your photo, and then turn it off. Just like we talked about in the high-speed video, your camera's only going to record light when light is present. So by only turning your light on and shining it around the objects that you want in your picture and then turning it off, you're going to get the brightness that you want on the foreground without it being overexposed. You're only going to capture light when your light source is on. And you can experiment with how long you leave the light on to get the best results. Thank you for joining us for this tutorial in our Imaging Science series with the MIT Museum and Koch Institute. We'd love to see your stunning science photos. If you'd like to share them with us, you can share them on Facebook, Twitter, and Instagram, and use the hashtag MITMImagingScience to share those with us. At the end of this program, so on June 20th, we'll be holding a webinar to look at what makes a great science photo, and so submissions have a chance to be featured during that webinar. For more information on the Imaging Science program, other tutorials and other information and resources, please visit the MIT Museum website at the link below, and you will find a list of our other resources as part of the Imaging Science program.